Alright, today we're going over 6.4, solving polynomial equations. So just to do a quick review with the difference of two squares. For example, if we have something like this, x squared minus 9, this is the difference of two squares, and this can be factored as the two conjugates. One will be a plus and one will be a minus, and then we take the square root of both of these. The square root of x squared is an x, and the square root of 9 is a 3. And this is by using the difference of two squares. The same thing happens if you had something, for example, like 4y squared minus 25. Then you would get, you look to see if you have a difference, we do, and if they're both perfect squares, and they are. So again, one is plus and one is minus. This is a 2y, the square root of 4y squared is 2y, and the square root of 25 is 5. These two binomials are called conjugates, and if you multiply them out by using FOIL, you'll get back to this quadratic binomial. So this is going to lead us into the next thing, which is going to show us how we get to the sum and difference of cubes. So let's say, for example, we needed to multiply a plus b binomial times this trinomial of a squared minus ab plus b squared. So what we're going to do is we're going to multiply a to every term. A times a squared is a cubed. A times negative ab is a negative a squared b. And a times b squared is an ab squared. Now we'll multiply b to every term. And therefore we'll get b times a squared is going to be a squared b, which is the same as if I wrote ba squared, but because I'm going to be looking for like terms, I'm writing it the same way. B times negative a times b will therefore give me a minus ab squared when I multiply that in, and then b times b squared is a b cubed. So now we're going to go ahead and combine our like terms here. So I have a negative a squared b and a positive a squared b. Those are going to cancel out. I have an ab squared minus an ab squared, also going to cancel out. And therefore we are left with a cubed plus b cubed. So therefore this is going to be our sum of cubes. So if I am going to write this out, let's write down the two formulas. If I have something that is a cubed plus b cubed, then you're going to first write the binomial, which will be the cube root of each one, so a plus b, this will have the same sign. And then you're going to have the trinomial of what we just saw, a squared minus ab plus b squared. And we just multiplied this out to show that this is true. This is called the sum of cubes. And then we will also have a cubed minus b cubed, and we will therefore call that the difference of cubes. And this will be factored as, instead of a plus, now we have a minus, so a minus b. And then notice how this middle term here was the opposite sign. That's going to happen again, where we have a squared. So the opposite sign will be plus a times b plus b squared. So let's try and factor one of those. And you can go ahead and write these down to have those as a guidance. Let's use the sum of cubes and factor 8 x cubed plus 1. So if we have this, then I'm going to write it in this form, something cubed plus something cubed. So we look at this, and I say, what is the cube root of 8? The cube root of 8 is 2. Because if I go the other way, 2 cubed, that means 2 times 2 times 2 is 8. So the cube root of 8 is 2. So this will be a 2x, and the cube root of 1 is 1. So 2x is going to be my a, and 1 is going to be my b. So this is going to be factored as 2x plus 1 times, here I put an a squared, so 2x squared minus my a times my b plus my b squared. And then we can clean that up a little bit, where 2x squared is 2 squared is 4, x squared is x squared, 2x times 1, so minus 2x, and 1 squared is 1. So this is factored. All right, the next thing that we're going to go over is actually finding the roots or the zeros when we're using the sum or the difference of cubes. So let's say, for example, we have a 2x or a 27x cubed minus 1, and that's equal to 0. So it's helpful to know what your perfect cubes are. So if we write down some perfect cubes here, perfect cubes. Well, let's list them. 1 cubed is 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 3 times 3 times 3, which is 27. 4 cubed is 4 times 4, which is 16, times 4 is 64. 5 cubed is 5 times 5 times 5 is 125, and so on. So we know this is a difference of cubes because they're both perfect cubes and we have a difference. So we'll first factor this. So we know we're going to have our a and our b, so it'll be helpful if you write it as something cubed minus something cubed, and then you'll know your a and your b. So 27, or the cube root of 27 is 3, because 3 times 3 is 9, and 9 times 3 is 27. And then the cube root of 1 is 1. So then we will factor this as our a minus b, and then we have our a squared, so 3x squared is a 9x squared. We use the opposite sign from here, or in the binomial, so plus a times b, so that'll be a 3x, and then our b squared. 1 squared is 1. We set that equal to 0, and then we solve. So when we're solving this, we still make our t-chart here. For this one, we'll get a 3x minus 1 equals 0. Add 1, divide by 3, and one of our answers is 1/3. So since we have a cubic here, we know that we're going to come out with 3 answers. Whatever the highest degree is, that's how many answers you're going to come up with. So far we have 1 answer. The next thing is we're going to use this quadratic and find the other 2 answers. So we look to see if this can be factored, and if it cannot, we're going to use the quadratic formula. So if we remember what that is, that's using the song of x equals negative b plus or minus square root b squared minus 4ac all over 2a. And then we plug that into our quadratic formula. So we get x is equal to a negative 3 plus or minus the square root of 3 squared is a 9 minus 4 times our a is a 9 and our c is a 1 all over 2 times our a, which is a 9. And then we can continue with that. So we can continue that up here. And we will get negative 3 plus and minus the square root of 9 minus, we do 4 times a 9 is 36. All over 2 times 9 is 18. And we continue with that. This will give us x equals negative 3 plus and minus. 9 minus a 36 is a negative 27. And then we look to see if we can factor that a little bit more. Coming down here again. So look to see if there's a perfect square that goes into 27, and there is. So we write it as negative 3 plus or minus the square root of, we always want to take out the negative part of the square root as well. So we go negative 9 times 3 all over 18. The square root of a negative 9 is 3i. We divide that by 18. And we could take a 3 out of all of these. So if we divide each term by a 3, we'll get a negative 1 plus or minus I square root of 3 all over 18 divided by 3 is 6. So this is 2 answers because of the plus and minus of it. Okay, moving on, we're going to start factoring using higher degrees, such as a degree of 4, which we call quartics. Quartics, you can think of quart, where we should think of the number 4. For example, there's 4 quarts in a gallon, right? All right, so let's say we want to factor x to the 4th minus 2x squared minus 8. So the first thing you're going to do is you're going to write it as a quadratic. So for quadratics, we know it's something squared, something linear, and our constant. So if we do that, if I write an x squared here, we know that if there is an exponent inside and outside, you multiply them. So 2 times 2 is 4. So we're not changing it, we're just rewriting it. And then I can make this an x squared also, because 2 times 1 will be 2. Then what we're going to do is we're going to say, let's let a equal x squared, or any variable you want here, and we're going to replace our x squared with a. So wherever I see x squared, I'm going to write a squared minus 2a minus 8. And then from here, we're going to factor it just like a quadratic. So we say what multiplies to 8 and adds up to a negative 2. So we can use negative, this is an a. So a, we use a negative 4 and a positive 2. Negative 4 times 2 is negative 8. Negative 4 plus 2 is a negative 2. Once you get to this step, you're going to replace your x squared for your a again, and therefore we get x squared minus 4, x squared plus 2. And that is factored. If it was equal to 0, then you would do your t-chart and you would actually solve for your x's, and you would get 4 answers.